Hi, welcome back to our discussion on waste disposal. In this section, we're going to talk about primarily toxic waste, and the other thing we'll talk about a little bit here is sewage. And we'll focus on disposal and treatment of some of these materials. Obviously, toxic waste we don't directly generate in large quantity, but they are generally made in a number of industries, and we use the products of those industries. With regard to sewage, we are involved in the production of sewage, and there's a couple ways that we go about treating that. Um, Sometimes we use the natural materials that are surrounding our house, and sometimes we have to go to bigger facilities to treat that material. In terms of industrial or toxic waste, it's mostly industrial, and the two big producers of this or types of companies that will make it would be chemical manufacturing, so companies like Dow manufacturing would produce plenty of chemical waste, and then petroleum companies, any kind of oil refinery, any company that makes plastics, right? 3M would be an industrial company that's going to create toxic waste as well. We'll notice toxic waste from an industrial scale here also. Waste treatment and disposal systems, okay, are making toxic waste, so they have a byproduct. And then lots of little things, coating, engraving, resin, and so on, are much, much smaller. So we see chemical manufacturing, petroleum, is taking up a really big piece of this toxic waste supply. Toxic waste is expensive to get rid of. It has to be deposited in what we call a secure landfill. The secure landfill is very similar to the modern, what we call sanitary landfill. It has the same basic construction. It has a clay layer on top, and it has compacted clay on the bottom. Typically, it also has is a plastic liner in this system, so it has not only a barrier that retards the flow of water, but also a barrier that is impermeable to water. And then all the materials stored in it are stored in a pretty orderly system in sealed containers. A lot of times toxic waste is liquid, okay, and so that material has to be held in a sealed drum, and this is why it's more expensive. You can't just dump it into a big hole in the ground. With regard to leachate and other things, you don't want any of this stuff getting out, okay, any of the leachate getting out. So you have more sophisticated leachate removal system. You might have a leachate treatment facility on site, as well as a lot more testing. So wells outside of the landfill are looking for any materials that might be escaping from the landfill and into the groundwater. Ultimately, this is the thing we're concerned about, right? Storage of toxic waste at the surface potentially leads to groundwater contamination. The other way we get rid of toxic waste, in this case, one of the things that's quite common is to inject salty water back into the ground. Okay? On the left-hand side, we see, say, a little USGS groundwater contamination diagram. But it's this deep well injection right here that we're interested in, right? The deep well injection, where we take it deep below the drinking water aquifer into an aquifer that contains what we call connate water. Usually connate water is left over from when the sediments were deposited, so it would be millions and millions of years old. The flow in these systems tends to be low and slow, so groundwater productivity movement is slow, and it tends to be sequestered deep. So these would be maybe in a well, it might be 5,000 meters, right? And so 5 kilometers down, well below the drinking water aquifer. Here we see buried wastes, right, getting into the system, disposal ponds. Okay, these are superficial things coming down into the aquifer, and then the deep well injection is supposed to be below that. It's supposed to be below an impermeable layer like an aquitard. You can see here our shale layer, which is going to keep it from getting up into the aquifer above. Obviously, though, shale layers are not always perfect, and we find that we get fractures and cracks, which can allow flow up into the aquifer as well. Okay, Another example, this is wastewater disposal well. Okay, Biscayne Bay, so this is in Florida Straits. Here's the drinking water aquifer up here. Okay, Upper Florida aquifer, confining bed, lower Floridan aquifer, and so sending that down to aquifers, injecting whatever waste it is back into the system to get rid of it. Okay, and then using the upper aquifer as our drinking water supply. So if you live in a home, like a standalone home out in the countryside, you may have a system like this, a septic system. And it's designed to handle a single home, waste from a single home. Water comes and everything really comes out of your house and comes through this little box. And this box is a septic tank, and it's designed to cause settling. So gravity here is the big, the big force at work. It will fill up with liquids eventually, and that liquid will flow up and out. And the liquid, the solid stays behind. Okay, that can be, and that materials we'll talk about a little bit later. But the liquid comes out into this gravel bed out here and through these pipes and becomes aerated, and it gives it a chance for it to break down naturally. And you can see absorption area needed based on the type of material used here. Gravel and sand uses less absorption, is more porous, more permeable. Okay, clay is less porous, less permeable, and so you need a larger area for your system out here, your septic system. But it allows for sort of filtering and the breaking down of the material that's coming out of your system. So really, treating sewage is a natural process. Now these systems can get overwhelmed, okay? And you could get a flood of too much liquid out here, and where the system just isn't performing, it's too saturated. Maybe you have too much clay in the system over here, and you don't have enough drainage. So a septic system can overflow and cause problems. From an environmental standpoint, if you had a drinking well over here, you'd have to be very careful about allowing the materials that are coming out of the septic system and eventually moving down into the groundwater. This is what they do, okay? But they're filtered after maybe 30 or 40 feet of rock, moving down into your well, okay? This puts coliform bacteria in your well and contaminates your drinking water and will make you sick. So the septic system and the drinking water system, especially in a rural community, need to be separate. And that was just something a geologist would have some knowledge about as well as someone who's constructing the home. In terms of large volumes of sewage, we typically have a two-step system, and some cities now have a three-part system. The first step in the system of treating large volumes, okay, is going to be right here. Okay, we're going to screen materials out, big stuff we don't want. Okay, and then we'll have sediment tanks for materials of certain mass to flow into and to settle out. So we're still collecting this material here through the force of gravity. The water then flows into an aeration tank where it gets pumped full of oxygen, which promotes bacteria growth, breakdown of compounds. Okay? And then it flows on, again leaving behind the final elements of material to settle out as this stuff we call sludge. Okay? And it flows to a new tank down here, okay, where it's then sanitized with a little bit of chlorine. We clean it and so that it can be consumed again. Okay, so it's drinkable. The sludge then is a waste in all cities, and it can be used it can be burned. That's one possibility. It can be recycled by burning it, but it also gets used in composting. All right, so it's a material that has a potential to be recycled if there's an economic demand, and that's the thing that really is required. No one's going to do anything if it costs someone less money to throw it somewhere in the ground. No one's going to bother, cleaning it up. Okay. There is a third component that some cities are now using, and some municipalities are using, and that's a filtration tank in which you might filter this material right through something like activated carbon to give you, another level of cleanliness. But this is the kind of system we're going to use here in the Chicago area. And in some cases, if this system, which takes a certain amount of time for the water to move through, right, because it's gravity driven, right, it's not a heavy filtration, we're not pressurizing the water or anything, it can only take so much water. Having the deep Chicago tunnels is helpful to try and keep this material from getting released into the Great Lakes. It does get released into the Great Lakes by major cities, and that is a serious problem, right? To release raw sewage into the cities, essentially cities' water supply. Okay, other cities have this problem. For instance, so LA typically has runoff that's heavy in the wintertime rain, and so you might not go swimming in the ocean because raw sewage or less treated sewage has been pushed out into the ocean by the sewage treatment plants because they can't handle the volume, and so you might get days where there's a warning you should stay off the beaches and so on. Okay, so that covers it for waste disposal, toxic waste, and sewage.